Hello again. Thank you for watching and studying math with me. This video is about applied word problems. This is a very challenging section for many students, but it is most important. You see, life is a series of often complicated word problems. Your book does give you some guidance into how to approach these problems. And this is useful, but you cannot learn to do word problems by memorizing these steps any more than you can learn to play golf by reading a book about playing golf. It can be a good thing to read the book, but you must play golf to get good at it. Similarly, you cannot learn to play basketball by watching highlight videos on SportsCenter. You have to dribble the ball and shoot the ball yourself. This video and the homework both provide opportunities for legitimate practice through a series of examples. Fast forwarding may seriously compromise your learning. Here is our first example. At 100% efficiency, two generators would produce 750 megawatts of power. At efficiencies of 75% and 65%, as you can see here, they produce 530 megawatts. So at 100% efficiency, what power would each produce? Press the pause button, do some work, try to solve the problem before you hit the play button again. Now we're back. So you see the two plants add together to give you, at 100% efficiency, 750 megawatts. That means that if you solve for G2, G2 is 750 minus G1. And 65% of G1 plus 75% of G2 is 530. Now we use this substitution that G2 is 750 minus G1 in this equation here. And we work through to solve that equation as we learned in a previous section. And we ended up with G1 is equal to 325 megawatts. And G2 then, by using this equation up here, has to be 425 megawatts. Let's look at a second example. A family has $3,850 remaining of its monthly income after making the monthly mortgage payment. And the monthly mortgage payment, which is 23% of the monthly income. How much is the mortgage payment? Again, what you should do is hit pause, do some work, and try to solve the problem before hitting play. Let's talk about the problem to be solved then. So after making their mortgage payment, if you take their income minus that, that is the $3,850. And that means, and another piece of information that we have, is that their payment was 23% of their income. So that means that I in this equation is P over 0.23. So what we will do is we can put P over 0.23 minus P, we're just substituting in that equation, is 3850. If we solve for P, we get P is 1150. Some of the equations will involve distance equal rate times time considerations. That's something that you're assumed to know. It's not going to be given in every problem. So here we have train A is 520 feet long and is traveling at 60 miles per hour. Notice that the units are different. Here are miles, there are feet. Train B is 440 feet long, traveling at 40 miles per hour in the opposite direction on an adjacent track. How long does it take for the trains to completely pass each other? So again, pause, do some work, perhaps solve the problem before you hit play. Now we're back. To completely pass each other, the rear of the 520-foot train must travel the 520 feet plus the 440 feet at a relative speed of 100 miles per hour, from which we have, and we must change this into miles, 520 plus 440 feet times miles per foot, that's the 5,280 conversion factor, has to be the same as the relative speed, distance equal rate times time. And so this is the time that we get in hours. So we solve this equation for the time in hours. We get this is the time in hours, and if we change that to seconds, using 60 seconds per minute and 60 minutes per hour, we end up with 6.5 seconds, a little over 6.5 seconds. Let's look at another distance equals rate times time problem. One lap at the Indianapolis Speedway is 2.5 miles. In a race, a car stalls and then starts 30 seconds after a second car. The first car travels at 260 feet per second. Again, those units need to be dealt with. And the second car travels at 240 feet per second. How long does it take for the first car to overtake the second, and which car will be ahead after 8 laps? Again, pause the video, do some work, and come back and hit play when you're ready to. So here we're going to let x minus 30, that is 30 seconds, be the time the first car started, and that means the second car started at x. Now they overtake each other whenever distance equals rate times time. So this is distance times time, distance times time. We solve that equation for x. We find that x is 390 seconds. Now, so whenever we look at 390 seconds and we look at the distance, we're going to see that that the total distance associated with 8 miles, or 8 laps rather, is 20 miles. We change that to feet, and then we see that that is less than the amount distance that was traveled in 390 seconds. That means that the first car is ahead after 8 laps. Mixture problems also are an important kind of application. We have here an outboard engine uses a gas oil fuel mixture in the ratio of 15 units of gasoline to 1 of oil. How much gasoline must be mixed with a gas oil mixture, which is 75% gasoline, to make 8 liters of the mixture for the outboard engine? Again, pause, work, and then play. Let x be the number of liters that are added. Now, we need to have a mixture that is 97.75% gasoline, and we're getting 8 liters, so x of it is what we're adding, that is pure gasoline, and that is 100% gasoline, or 1 as a fraction. And we're comparing that to 75% gasoline, and that's the balance, which is 8 minus x, because together they add up to get 8 liters. So we will take the concentration times the 8, has to be what we get from the pure gasoline, plus 75% of the rest. This equation we solve and we get x is 6 liters of gasoline. In class, we will be working on other problems in groups and supervised study, but the serious student will read the examples in the book and work some additional problems on their own. Until then, remember, time is precious, each day must count. Doing the math will make you strong. Take care, and I'll see you in class.